Hello everyone, this is Mr. H again, and welcome back to my YouTube channel. In this video, I will go over with you the rest of the parent functions. This is actually a continuation of the last video, which is the first part of graphing parent functions using table of values. Alright, so if you haven't watched the previous video, you can check out the description box. The link to that video is posted there. Alright, so let's jump straight into the very first example. Alright, so in the previous video, I explained to you what parent functions are, right? I'm sure that you still remember what parent functions are, and parent functions are the simplest forms of functions within a family of functions. Alright, so for this example, you're looking at what we call an absolute value function. And for absolute value function, we don't have any restrictions for the domain or the x values, the set of x values. So that means any x values, as long as they are real numbers, are fine. Whether you put in negative numbers or 0 or positive, definitely you will always get an answer that is a real number. So for this example, I would like to pick and assign values for x, negative 7, negative 4, we pick 0, positive 2, and positive 5. So it is always a good idea to include at least one negative value and then the 0 and then one positive. But then again, like what I explained in part 1 of the video, it will always be dependent on what function you are dealing with, because there are functions that have restrictions on the value of x that you can use. So let's get back to the example. Alright, so if x is negative 7, the absolute value of negative 7 is positive 7. If x is negative 4, absolute value of negative 4 is positive 4. 0 will be 0. Absolute value of 2 is 2. Absolute value of 5 is 5. And those are the sets of points that we need to plot on the coordinate plane. So remember, you have here the x-axis, which is the horizontal number line, and you have here the y-axis, which is the vertical number line, and these are the sets of points that we need to plot. All right, so we have negative 7 comma 7, we've got negative 4 comma 4, we've got the origin 0 comma 0, we have 2 comma 2 and 5 comma 5. So the first point we have is negative 7 comma 7, and that is here. Next is negative 4 comma 4, and we have 0 comma 0, 2 comma 2, and 5 comma 5. So that is the graph of y equals absolute value of x. Alright, so let's head on to example number 2. So we have here y equals 1 over x. So yeah, we call it reciprocal function. Before we choose the values of x that we want to use for the table of values, let's talk about the restriction. So it's very obvious that here x must not be equal to 0. And the reason why is, if x is 0, definitely it will be undefined, right? So any values of x will do as long as they belong to, real numbers and not 0. Alright, so let's pick some values for x. So for this example, I would like to pick these values. So x will be, okay, say 0 0.25, 0 0.5, 1, 4, and 8. So as you can see, I picked all positive values, right? So later I will explain to you after completing the table and plotting these set of points, okay? All right, so if x is 0 0.25, so it will be y equals 1 divided by 0 0.25, that is 4. If x is 0 0.5, the value of y will be 2. So 1 divided by 0 0.5, it will be 2. So obviously, if x is 1, then y will be 1. 1 divided by 4 is 0 0.25, or 1/4. 1 divided by 8 is 0 0.125. Then we need to plot those points. So obviously, I picked all positive values of x, so definitely we're expecting a graph that is gonna land in here, quadrant 1. So I have here the x-axis and the y-axis here. So if x is 0 0.25, then y is 4. That's the first point. 0 0.25 and 4. Next, 0 0.5, which is half, and then it's 2 here. If x is 1, then y is 1 here. If x is 4, then 0 0.25 here. You see, it's gonna get lower. If x is 8, 0 0.125 is very low. And we need to connect the dots. So it's not going to touch 0. My graph is not drawn perfectly, but you can get the idea from the table of values that I presented to you and how each point is located on the grid. Now, I mentioned earlier that I picked the positive values of x because for a reciprocal function, okay, so if you're gonna pick the negative counterparts of these numbers, obviously you will have the same values, but negative. If you picked negative 0 0.25 for x, definitely your y will be negative 4. Yeah, same goes for the other values. If x is negative 8, definitely the y of negative 0 0.125. It only tells you that this graph right here will have its reflection here. There you go. So that is the graph of a reciprocal function, y equals 1 divided by x. Alright, so if you're enjoying watching the video so far, please hit the like button. If you haven't subscribed yet, so please hit the subscribe button as well, and the notification bell so that you won't miss any of my future videos. Alright, so let's take a look at example number 3. Alright, so example number 3, you're noticing that the variable x is in the exponent, so it gives you the hint that this function is exponential. So this actually came from y equals b to the power of x. So we don't have any restriction here for x because the value of x here can be any, real numbers. Any values you assign, whether it's negative, 0, or positive, it will be okay. But then the restriction here is for the base. this one, right? So the base here, or b, must always be greater than 0, and b must not be equal to 1. Because if the base is 1, definitely you will always get a number that is 1. 1 to the power of negative 2 is going to be 1. 1 to the power of 0 is going to be 1. 1 to the power of 1000, it's going to be 1, right? And for this example, I would like to pick -7, -2, 0, +2, and +3. Now, if x is -7, so 2 to the power of -7, it will be 1 over 128. Say it's equal to 0.0078. Now, if x is -2, definitely 2 to the power of -2 is 1/4. 0.25. 2 to the power of 0, any number raised to 0 will be equal to 1. So if x is 2, 2 to the power of 2 is 4. 2 to the power of 3 is 8. Alright, so let's plot those points. If x is -7, y is 0.0078. You can say that it's here. It's very, very close to the x-axis, right? But it will not touch the x-axis. All right, so that is the point over there. The second point will be -2, 0.25. -2 is here, 0.25, say it's here, so a little higher. If x is 0, then y is 1, so there you go. If x is 2, then y is 4, so here. If x is 3, then y is 8, so it's here. Then we connect. There you go. So I know it's not perfect graph, but there. So that is a graph of y equals 2 to the power of x. So again, remember the restrictions for the base. And let's head on to the very last example. So graphing logarithmic function. All right, so we will talk about the restriction for the domain or the set of x values for logarithmic function. So say we have here. So this one, we call it the argument. Okay, so the restriction will be x must always be greater than 0. Or we should say positive real numbers. We can pick 0.25, 0.5, 1, 4, and then 8. All right, so if x is 0.25, the value of y will be, so log base 2 of 0.25 is -2. So if x is 0.5, log base 2 of 0.5 is -1. And then if x is 1, will be 0. So if x is 4, then y will be 2. If x is 8, y will be 3. So if x is 0.25, y will be -2. So here. If x is 0.5, then y is -1. And if x is 1, y is 0. So here, if x is 4, then y is 2 here. If x is 8, then y will be 3. So it should be here. There you go. So sorry about the graph. It looks like it's touching the y-axis, but if the graph is perfectly drawn, this graph right here will not touch the y-axis. It's gonna be getting closer and closer and closer to y-axis, but it's never touching it. So this is the graph of y equals log base 2 of x. Alright, so this is the end of part 2. So if you learned something new from this video, please give me a thumbs up, share the video, and if you haven't subscribed yet to my YouTube channel, please do so. And once again, thank you very much for supporting my YouTube channel, and I will see you in the next video.